Hello friends, so we are back with another video that is regarding carrot. Now this time the vegetable is carrot. The problem is same, but the fungus is different. In this case the fungus is Ostocella. Now this fungus is because of osto means 8 and cell means cell. So it grows in the parity of 1:8 cell. So this is a very fast growing fungus. So 1 becomes 8. Generally the fungus develops in 1:2, 2:4 like that. So, but here it is 1:8 and 8:16 and 16:32 like that, 16:24 like that, 24:32 like that, 24:32 like that. So, it grows. So, it is a very fast growing fungus. So, let us see whether it is Ostocella or not, but it looks like protrudes, it has a protruding head over the carrot. You will see in my video and then later on later part of this video that it is protruding like a carrot. So, this is a very dangerous fungus, as I can presume. This is known as Ostocella. So, let us see how it looks like, and we will be doing for the microscopic examination and what happens. So, this is also the same problem, the refrigerator. It was stored prolonged time in a refrigerator, and it cannot caught this fungus. Generally, these fungus are very dangerous because we can say that we can cut off the carrot, the part of the fungus affected carrot we can cut off, and the rest of the carrot we can eat. But no, what happens sometimes these funguses, they protrude a root inside, and this root can grow more funguses from there. So, they have a penetrating structure inside the vegetables, other part of the healthy part of the vegetables. So, that we have to, so the whole vegetable should be discarded. If it is seen that it has got fungus, then the whole vegetable should be discarded. It is not that part of the vegetable is cut off and the part is kept. No, this is not done. This is not this is economical, but this is not done. Or later on the money will go to the doctor. So, this is not done. So, what we have to keep a close eye that if the fungus is caught, then we have to throw out the vegetable. So, let us see, we begin with the later part of the video that how it goes. Thank you very much. Hello friends, so we will begin our experiment, and we can see, as you can see, the fungus is in this tube. I can see in the camera the fungus is in the tube. So, I am going to take out the fungus with the help of this forceps. So, and if I take out the fungus, it is already very soft. It has become very soft. As you can see, the carrot has become very soft, and as you can see in this camera, if I show you, so this is the structure of the fungus, as you can see in this camera. So, if we move all around, and this is the fungus. So, you can see in this camera also, perhaps you will be able to see in this camera. So, this is the fungus. So, it is focusing, the camera is focusing, as you can see. So, this is fungus. I will show you the laparoscopic view also. Before dissecting, I am going to show you the detailed view from the laparoscope, so that you will see. So, this is the protruding fungus. So, I will show you in the laparoscope. By the help of the laparoscope, I will show you the detailed position of the fungus, why it is known as Ostocella and all that. So, that I will also show at the next part of this video. So, let us see the fungus in details by in the laparoscope. Oh, here is the carrot acquired by the Ostocella, and the laparoscope. As you can see, the protruding structures of the laparoscope, and this is the main fungus, main black portion of this fungus. As you can see, the protruding structure and the roots, and this is the necrosis part. This fungus has just started. This is the necrosis part. This is the necrose. The necrose has started. So you can see the black. This is the fringes, the main Ostocella fringes. These are the fringes type of Ostocella. You can see the two types of Ostocella. One is the mold, and other is the necrosis. And the fringes, the necrosis has started, and this is the necrosed part, the complete putrefied necrose, and above that there is the necrose. So this is the Ostocella fungus under laparoscope. That is the black necrose, you can see. So this is the necrose again, the necrosed part again. So the another part of the necrose, this is the posterior structure of the carrot. So this is the healthy part of the carrot, but you can see the yellowish and the black patches over there. So it has already affected the fungus. So this we cannot leave, this we cannot take, so we have to discard this fungus. So the whole carrot has become putrefied and it has been acquired by Ostocella. So this whole part of the carrot has been acquired by, this is the posterior part of the carrot. As you can see, these are the fringes in the posterior part. So this is all up. So friends, we are going to, as you've seen the laparoscope, the structure of the fungus, and I have explained it in my part of the video. So therefore you have seen, as I have told you in my first introduction, that the roots are there. You can see, you have seen in the laparoscope, the structures are protruding from the healthy part of the carrots also. You can see fine structures in the healthy part of the carrot. So this is the beauty of the laparoscope. So you will be able to see from the laparoscope that the healthy part also consists of fungus. It has become white. So in normal eyes, in naked eye, it is not visible, but in laparoscope it was visible. So now we are going to dissect the fungus with the help of a scalpel and a forceps. We are just here ready with the tool. So we are just going to take part of this fungus out and we are going to give it into the culture media. So just, it has become very soft. It has become very soft. So we are just going to dissect the fungus. It is just like a sponge. So Ostocella is a sponge fungus. So we're going to dissect this whole thing and we are going to put this into the culture media. We are going to put this into the flask and after that we will put into the culture media. So this is the sponge part is gone and we are taking the necrosis part. So this is the necrosed part, the just starting of the fungus, and rest of the body is done. So this is soft and this is the healthy part, but only a bit is healthy, but still we are not going to take that. And some necrose part is over there also. This is also the beginning of the necrose. The whole fungus, the whole carrot has become very soft, like a sponge. So over. Now we are going to put the culture media. As you can see, just you have to keep the knife very carefully, knife and the forceps very carefully. Now we are going to take a culture pipette and just a measuring glass pipette and we will be, this time we are using sodium acetate differential agar. As you can see, this is sodium acetate differential agar. So around 15 ml we are going to put. So this is a very big amount of the fungus. So we are going to take 15 ml of this fungus. So this is 0 and we are going to take 15 ml. So this is 5 ml. So this is 5 ml and this is another 5 ml is coming up. So another 5 ml coming up. So this is 10 ml. Another 5 ml we need because this is a very big fungus. So we are going to take another 5 ml. Pipette is a little bit slow, but it is working. So this is 5 ml. So it is done. So now our work is over. Today's work is over and we are going to put this, discard this pipette, and as usual we are going to cork it. I have shown you different times, multiple times is how to cork. So this time you can understand. So that is the same way we are going to cork the cotton and the, like that we are going to cork and the cork is done. And the cork is done. So let us sprinkle some alcohol and the cork is done. So it is done. So this is our fungus culture, initial culture, it is green. So within after 10 days or 5 days we will come back. After I think within 2 or 3 days we will see. So because this is a very fast growing fungus, so that after 2 or 3 days we will see. This is Ostocella, and today is 5/9/22. So today is Happy Teachers Day. So good luck to the teachers, the future teachers, and good luck to the students. Thank you very much for today. Hello friends, so we are back just after 48 hours with that carrot, putrefied carrot. What I have said that around it is Ostocella. Now it has proved its incubation period. After 48 hours it has shown it is fully grown. It has shown its growth and it is fully grown. So today we are going to do the first investigation. We were going to study the cellular structure of the Ostocella, and later on we will be proceeding for our advanced studies, that is the fluorescence study and the extraction of the mycotoxin. So Ostocella is a very new fungus. Its mycotoxins are not known. Even its fluorescent structures are also not known. So we are going to see what is the structure of the Ostocella and how it looks under the fluorescent microscope. Generally it is a mold, but it will show some similarity with other molds, but some difference will be there. The cellular structure, the difference in the cellular structure will be there. So that we are going to study. So let us proceed for the first microscopic investigation, and then after 1 or 2 days we will study the fluorescence and the mycotoxin. So let us begin the experiment. So friends, we have started our video after experiment, and you can see the camera, both the cameras you can see. Yes, this camera is recording. Let me see. So this camera is also recording. Yes, it is recording, and as you can see that we have begun the video, and let us see the fungus. So from the equation of around 1.5 ml or 8 ml, this is a very thick fungus, so we have to aliquate less. So we have taken the mold, and here is the mold, but as you can see this is a very thick mold, little bit more, and it's a very thick mold, and this is the mold. So as it is a very thick mold, we are going to lacerate this mold by using a very special kind of buffer, and that buffer is known as p-toluidine sulfonamide buffer. This is a decluster buffer, as you can see in this camera, as well as in this camera you can see. So this is a declusterification buffer. So we are going to take around 1 ml in this buffer. So we are going to take 1 ml in this buffer, and the ratio should be 10%, and this is a 50 ppm solution. So this solution is 50 ppm. So what we are going to take? We are going to take only 1 ml of this solution to declusterify it, and this is 500 ml, and this is also 500 ml. So we are going to take 1 ml of this solution to delacerify the fungus, and that we are going to see that will make us easy to see the fungus. And you can see under this camera that it is already been lacerified. So this is already, it has been declustered, and the clusters are very small now. Not very small, but it is small enough to see under the microscope. So if it is a very big structure, the structure is very big, then it will be difficult to see under microscope. You can't magnify it. It is previously magnified or pre-magnified, so that you cannot magnify. So to magnify it, you have to see this thing. So let us begin with the other part of the microscopic investigation. So thank you very much. So you can see the Ostocella. Now this is the Ostocella mold, as you can see, and this is a big cluster mold. Still after declassification, the mold is still a cluster. You can see, but we are trying to see the cellular projections or the cellular orientation, and some other clear parts we are trying to see the cellular orientation. So let's move the specimen. We are moving the specimen. It is around 10 to 100x magnification, and we are trying to visualize the mold. And here you can see the clusterification. It is in a order of 8, but the clusterification is so congested that the clear view of the 8 formation is not found. The magnification is changed again to higher magnification, and the microscope is focused, and it is now microscope is trying to be focused, and you can see the clusterification very well now. It is in the cluster formation of 8, in order of 8, and this is 200x magnification. So this is the Ostocella, and it is a mold formation, and again we are magnifying it, and it is again 100x magnification, and still it is showing the clusterification. As you can see, we are moving to other parts, and this is a very big mold, as I have told you. So still after reduction, the declusterification, it is still the mold is there. So this is one. This is all about Ostocella, and as you can see, it is being done. So these are the other parts of the molds. The protrusion, there's a protruding roots are there. The colony form. This is also very clear to black fungus. It is very near to black fungus. It is looking like black fungus. Some protruding spouts are coming out from the base, and you can see some other parts. But this is almost over. The slide is almost over. So this is the lacerated Ostocella. The structure has got lacerated due to p-toluene sulfonamide, and it is some other parts, some sprouts are there. These are the sprouts. This is the magnified view of the sprout. These are the magnified view of the sprouts, as you can see. So these are the magnified views of the sprouts, lacerated sprouts, that is detached sprouts. You can see very well, and this is Ostocella Flaveola. This is Ostocella Flaveola. You can see this is the Ostocella and the fluorescence. So you can see the tiny Ostocella colonies, and this is a very beautiful colony. And you can see below it is the excess fluorescent stain, which is not yet washed out after bluing. Anyway, you can see the Ostocella colony on the top, and you can see now the Ostocella formation is there. The flat chain-like objects you can see. Those are the mature Ostocella colonies. And you can see the chain-like structure is in the configuration of 8. So we are trying to show you the formation of 8 conjugation of 8 cells. So this is the Ostocella colony in front of you. The microscope is focused, and you can see the Ostocella colonies. And so this is a very beautiful colony, you can see. And the most dangerous fungus of all, and it consists of 4 mycotoxins. So here you can see in the corner, there is the 8 configuration of 8 in the 2 straight lines in the right angle formation, which is marked in the yellow circle, white circle. So there you will be able to see that this is the 8 configuration of 8 cellular configuration, the configuration of 8 cells. So there you will be able to see So this is the Ostocella configuration. It is a chain-like thing, a flat chain-like thing, consisting of 4 mycotoxins: the botrytis, the trichothiocin, and the roquefort and is there. So this is the other part of the Ostocella fungus. These are the main parts. The patches, the colony, flat colonies, the confused colonies, the fused colonies. Is a very conjugated concentrated fungus, and these are the other parts, and mostly the slide is complete. So that's all. So this is the spectrum of the Ostocella Flaveola. This is the mycotoxin spectrum of the Ostocella Flaveola, and as you can see, the 4 mycotoxins are visible. This is botrytis, trichothiocin, roquefort and Baccarin. So another 2 pieces are at of the solvent, that is acetonitrile and TBAHs. So that is not relevant, but these 4 mycotoxins are visible. So this is a dangerous fungus, as I can say, with having the trichothiocin mycotoxin with botrytis and roquefort and Baccarin, a new mycotoxin called Baccarin. So this is all about.